it going, guys? My name is Dylan and I am the new machinist at FDF. Josiah decided that basically he wanted to create as much in-house as possible, stop relying on other companies to get us our parts when we need that. So this is the machine that he bought. This is a Haas VF2 SS. SS means our rapids and our spindle RPM is actually a little bit higher than a regular one. So that'll give us as far as the production base goes for even parts like this right here. When we have a run of 50, 60, 70 parts, it's going to cut down on cycle times, lets us be more efficient. So yeah, that's basically it for the introduction on the machine. So we're going to briefly go over how we take a piece of stock off of the water jet, which looks like this, and then finish it to a piece where a cam can weld it to the knuckle itself. So we use Fusion 360 to program all of our parts for the Haas. And we'll just quickly go over the design here. You can see we have the model. We also have our fixture plate that we're using in the machine. And then if we go into, so now we can kind of see our different tool paths selected. And then this program here is what will basically give the machine a language to then machine the part, tell the tool where to go, what to do, and then we can now go back over to the machine and I'll show you how we run and load the parts. What are we gonna say? All right, so right now the machine itself is running our second operation. We have all of these guys here behind me have run through our first op. So you can see along the side, we've done our contour and our profile. We've also done the inner diameter. And if you zoom in here, Jack, you can see that little lip right there is going to be how we hold the part down for our second operation. So what we have to do is basically keep in mind, once we go on to our next operation, how we're gonna hold the workpiece the most efficient way to be able to do what we need to do. So as you can see, the machine itself is running coolant right now. What we use the coolant for is basically to keep everything cool. It drastically increases tool life. It lets us run it a little bit faster, helps keep the chip away. And then you can also see the machine itself has an auger, which will bring all of the chips out here into our chip bin. And the coolant itself will then drain back into this main tank here. And then from there, coolant pumps to the machine, up to our spindle, and then we aim it where we need to go. Okay, so here, this will be our second operation. What we're doing is now holding it from the middle like we had talked about here. We come in, we do a chamfer, an edge break around the contour, the inner diameter, and the holes. And then we'll also come in and just quickly take a skim just to make aesthetic purposes, basically. And from there, we'll then take these parts, load it into our chuck, and then run off the reef. All right, so here we are. This is the part after running our third operation on it. Coming off of the machine, that's everything that I have to do to the part to get it to cam. So here, all we did was, if we reference this part, we now take off the lip. We cut it down to size. So we'll just check that quickly. We're good on the size. We know our diameter is already good. We've chamfered the edges, and now that's good to go. That's how you make a part.